Hello and welcome to week 6 of the Philosophy of Mind course that I'm running at LaGuardia Community College. My name is Dr. Richard Brown, and we're going to be talking about the mind-body problem today, which is appropriate since I have been feeling kind of ill and not quite well. So I've taken some Advil cold and sinus. Hopefully that'll help a little bit with the aches and chills. Um, but it's a perfect day. It's rainy outside. I've got my hot lemon tea and my Advil sinus cold and sinus. And what better way could you spend a day than by talking about philosophy of mind? So let's go ahead and start. And I want to remind you just where we are in the class. So this is roughly speaking the second half of the class. Uh, we have a 12-week semester, as opposed, and other places traditionally have a longer semester, but we have a shorter one because we have longer classes every week. So instead of 50 minutes, we meet an hour a week. And that's a weird thing about the way that LaGuardia does things, which is not the way other CUNY schools do things. Okay, so that's a bit unusual, but and I've structured it this way. So there's roughly going to be 12 videos. And this week, video 6 through 12 will take us from questions about phenomenology and looking at consciousness from the inside and our access to it, and etc. And we're going to be talking more about metaphysical issues. And so, of course, the big metaphysical issue is the mind-body problem, which we're going to spend this week talking about. But the problem is really so big that we're going to have to spend 2 weeks talking about it. And so next week, we're going to look at the view known as epiphenomenalism and some important discoveries which have suggested that the physical world is causally closed. And then also our most contemporary, current, cutting-edge physical theory, quantum mechanics. Some people think that these things play an important role. So we're going to look at this and see, ultimately the issue is, can the mind and the body relate to each other and interact with each other if they are distinct from each other? And I'll be presenting the case roughly that if they are distinct from each other, then it becomes very mysterious how they could interact, which I think is widely accepted. And of course, if you really believe that the mind and the body interact with each other in a significant way, that's a significant thing to find out. So now, after that, we'll turn to looking at the traditional physicalist views. So instead of saying they're distinct, maybe they're sort of the same thing in some sense. And starting with in the early 1950s, a group of philosophers that were interested in the developing neural science came up with what's known as the mind-brain identity theory. And so we'll look carefully at that. And then, of course, not only is there neuroscience, but the development of computer science gives us another approach, which is known as functionalism. And then those two interrelate with each other. We have computational neuroscience, for instance. And so that's something that's very important. And then, of course, after we look at the kind of main developments in the 20th century, we'll look at the reaction against that from the contemporary property dualists, look at the arguments of David Chalmers, the zombie argument, the knowledge argument of Jackson, and the kind of view that develops out of that, a kind of what's called Russellian monism, the idea that consciousness is a fundamental entity in the world, is getting a little bit of attention lately. So we'll look at the arguments that push in that direction. And then week 11, we'll turn to questions about artificial intelligence, simulation and singularity, and machine consciousness, which are super interesting, and they're closely related to the questions about computation and functionalism. And so that's a very exciting and interesting thing. And then, of course, at the end of the semester last week, we'll turn to looking at eliminativism. And eliminativism is the view that consciousness doesn't exist, or the mind doesn't exist, or at least not in the way that we think that it does. And so we'll close by looking at two traditional challenges in this area, one from the Churchlands, claiming that neuroscience is going to lead us basically to get rid of these things we're talking about, and the other from Dan Dennett, who claims that just the idea of consciousness as developed through um, through this class is incoherent and ultimately is not going to be there. So that's where we're heading. A lot to cover. So let's go ahead and get started. Now, right off the beginning, when we start, we want to say, well, if we're asking the question, is the mind physical? Are they distinct? Are they the same thing? What is the relation between them? Well, we want to be able to say something about the difference between them. So commonsensically, we distinguish the mental from the physical. And you may remember as far back as when we were discussing Brentano in the early week, second week of this class, we talked about intentionality and thought. And Brentano sort of argues that intentionality is the mark of the mental. And he contrasts that with, seeing a table, which he calls seeing something physical. And now you might wonder about that because that's just an ordinary common sense notion, and that doesn't automatically prove that simply because we use these two words in this way that they are distinct, because it could be the case that we simply mean, oh, it's not like the stuff out there, like a table and a chair, that somehow it's got some other interesting properties. Then we might wonder what those properties are. And it might turn out that those interesting properties really are special kinds of physical things. So right at the beginning, we recognize that we have this common sense dichotomy, the mental and the physical. And we talk about them in different ways, but that doesn't show us about the metaphysics or the true nature of these things. It still could be a case that we use the word mental and contrast it with physical, but ultimately that thing turns out to be really just a special kind of physical thing, like maybe something in the brain, for instance. So this brings us to the question which is at the heart of our discussion today, which is, what is the relation between them? We talk about them as though they're different. Are they really different? Maybe they're not. Maybe, as I suggested just a second ago, we'll discover that even though we talk about them as though they're different, they really aren't different. So this is the mind-body problem. And the basic problem is the question, what is the relationship of the mind to the body? And even though in a typical class like this, you would be, excuse me, sorry if I'm a little bit coughing and sipping on my tea, but functioning at below normal levels here. So it's clear that there is a relationship between the mind and the body, as I'm clearly experiencing at the moment the effects of that relationship. That's why my head is cloudy and my I feel a bit nauseous and achy. There's something physical going on, which is producing those feelings or conscious experiences, as we would commonsensically say. And then also those produce physical effects like that. I'm complaining, for instance, about how I feel and sipping tea instead of something else, and all of those interesting things. So, and this, of course, is not news to anyone that these things are talked about in different ways, but yet they seem related to each other. And so Socrates, who was executed by Athens 399 years before year one, that's what the BCE means there. So not really clear when Socrates was born, but we have a firm date for his death. And of course, Socrates' most famous student was Plato, and Plato lives from 427 to 347. And as an exercise, you can figure out whether 347 is before or after 399. And of course, the answer to the exercise is that it's after, because on this side of the timeline, we're counting down to 1. And you can go and I have a lecture on this in the intro class about timelines, and I don't want to get too hung up on it, but the basic point that I'm trying to make is that Socrates and Plato were dualists who believed that the mind was separate from the body, and they wondered about the relationship of the mind to the body. And so, there's in the Phaedo, Socrates wonders or talks about whether it's like the way we have a relationship with clothes. So the same soul wears many clothes. Is it in? Is it wrapped around? I mean, there's an interesting question which arises once you think that they're separate. And we're not going to spend time on the arguments that they give for why it's separate, because that's really more of a ancient philosophy class, or in the intro class, I talk a little bit about this. But one of the interesting things to note is that if you squint enough and look back at history, it looks like Plato's giving an argument, or at least one of the arguments he gives depends on things we would recognize as maybe something like intentionality. So, for instance, Plato has his theory of the forms, and the forms are supposed to be these eternal, abstract, non-physical, unchanging archetype things, which are related to physical objects by something called participation, namely the physical objects participate in the forms. And so when you're one way of reading this stuff is that when you think about the table, you're really in contact with the mental abstract object tableness, and you're relating it to the thing there, and that can sound a bit suspiciously like Frege. And so there's are interesting connections there because Frege was a Platonist. But I don't want to get too distracted with trying to put on our modern glasses and read off of read things in the history that aren't there. But one of the arguments that is commonly called the argument from affinity goes something like this. Well, these things that we think about in mathematics, Plato thought it was sort of clearest. When we think about mathematical facts, they're stable, they don't seem physical, they don't change, but yet we're able to somehow connect to them with the mind. And so how is it that the mind is able to connect to non-physical things? Well, it must somehow be like them in the sense of being non-physical. And so now that's you might think, that's a really interesting and tortured way of trying to say intentionality or the very act of representing or thinking about the world means that the mind is not physical. Now, I'm not saying that they're right, obviously, or that they're wrong, or that this is even the right interpretation of the kind of affinity argument that Plato gives. But I think it is one way of looking back and seeing that this idea that fitting in the mind and thinking into a sort of naturalistic framework is hard. But that doesn't mean that no one's ever tried to do it, of course. And sometimes you find people in these discussions talking as though dualism has always been the dominant view, and that it's somehow more just kind of common sense or obvious, and that it's harder to find people defending materialism. And in the history of philosophy, I don't think that's true. So if you want to find someone from this same time period as Socrates and Plato, but who was a materialist, then you need look no further than Democritus. And you could see his dates there, 460-ish, it's not really clear. He dies in 370-ish, and so you can see how he overlaps with Socrates and Plato if you care to see that kind of stuff. Our point, of course, is that Democritus is a materialist. He argues that the mind, or what the Greeks called the soul, the psyche, the anime, whatever words you want to use there, what Democritus claimed was that it was composed of what he called soul atoms, which were a special kind of atom. Just like other atoms, though, they were distinguished merely by their shapes. So whereas non-soul atoms had different shapes, like square, triangular, and so forth, Democritus argued that soul atoms were spherical, and that allowed them to slip around and interact in the body wherever they needed to be. So that's how you could feel things in your fingers and see things with your eyes, according to him. So, again, I'm not, and if you don't like atomism of this Greek variety, that's fine. You can, if you don't know what it is, you can go watch the video I have on the pre-Socratics. And I talk about Democritus and Elisabeth there a little bit. And again, I don't really care how much you know about this stuff. The point I'm trying to make, though, is that, well, you have to tell a story about how the mind is related to the body. Here's Democritus's story. The mind is composed of these little spherical atoms, and it's distributed throughout the body along with the other atoms, which are just merely physical things. And because of its unique shape, it has these properties. So that's an account of the relation to the mind of the body. The mind is the body in a certain sense. Whereas Plato and Aristotle deny that. Plato and Socrates deny that. I was thinking of Aristotle because he was coming up next and speak of the devil, there he is, though obviously he's not the devil, or, well, I don't know, it depends who you talk to. So Aristotle, 384 to 322, again from this period, and you can look and see how he overlaps. But his view about the mind is that it's distinct but dependent on the body, and this view is consistent with his general view called hylomorphism. And some people look back and say, this sort of sounds like functionalism, and you maybe don't know what that is yet, but we'll get to functionalism eventually. I'll here just kind of flag it because it might be fun to, when we do eventually get to functionalism, it might be fun to look back and say, okay, so does this look anything like what Aristotle had in mind? So what he does say, though, is that the relationship of the mind to the body is that the mind is the form of the body. The material is the body, the form is the mind. And the analogy seems to be something to the analogy of the shape of a statue to the material the statue is made out of. So if you have some statue, it's made out of clay, that's the material. But if it's shaped like Socrates, then that's the form. And of course, the form is transmitted into the material through some activity, namely the sculptor doing something, and it's the art being active. I mean, there's a whole story there. And I don't want to derail this into a discussion of Aristotle, though if you've watched my previous videos, you know I like discussing this stuff. The point, though, is that he gives a story about the mind as somehow being distinct from, but dependent on the body. So just like the shape of the statue, he thinks is independent of the statue, because you can destroy the statue without destroying the material. So the clay doesn't get destroyed if you break the statue. And he thinks, well, since they have different conditions of persistence through time, they're different things. Now, that's an interesting view, and hylomorphism, to be honest with you, has been neglected in the contemporary discussions of this stuff. So I think it's cool to point it out. There are some people getting interested in it again, and when we get to the end of this class, after we've sort of done the traditional stuff, we'll look back and try to refresh our memories and update a little bit some hylomorphism. So that's cool. So the basic point of this is, even though this stuff starts in the 17th century, in the 1600s, and that's where, if you really care about the mind-body problem, that's where it gets put in the way that we still talk about it. It's not where this problem starts. It's an old and obvious problem. Okay, so moving ahead then to the beginning of the scientific revolution, and you could start arbitrarily at any point in history, but it's traditional to start with Galileo. And Galileo lives 1564 to 1642, and he's a super interesting guy, very, very smart. He develops the telescope in some greater accuracy, and etc. So we're not, again, going to be distracted, but the point that we want to make about this Galileo is a nice quote from his book, The Assayer. And here's what he says. He says, philosophy is written in this grand book, I mean the universe, which stands continually open to our gaze, but it cannot be understood unless one first learns to comprehend the language and interpret the characters in which it is written. It is written in the language of mathematics, and its characters are triangles, circles, and other geometrical figures, without which it is humanly impossible to understand a single word of it. Without these, one is wandering around in a dark labyrinth. So this is where that famous quote that the book of nature is written in the language of mathematics, that's a condensed way of putting this. That's where that comes from. And this kind of symbolizes the big idea which is being developed at this time, which we call the beginning of the scientific revolution. So the basic, they're formalizing the scientific method of experimentation and testing of hypotheses by experiment, but they're also developing the idea that nature is described or works according to mathematically formulatable laws. And of course, as you can see right here, Galileo's thinking in terms of geometry and geometrical laws. And that befits a person in this time. Calculus hasn't come around yet. And the mathematics of the day is geometry. So there's an overturning, a throwing over of the old way of doing things and a putting in place of a new way of doing things. And the old way of doing things was Aristotle's way, roughly. And again, I won't go into the story, but watch the videos on Aristotle and Descartes from my intro class, and there's a lot of detail on this. But the basic idea, which we can sum up, is that that the world is really divided into these two kind of areas, which Aristotle had sort of all lumped in together. So this idea is most clearly formulated in Renee Descartes' work, who was alive around the same time. You can see 1596 to 1650. You can see his relation to Galileo. And though they didn't know each other, Descartes was a mathematician. He was a physicist. He's most known as a philosopher nowadays, but as we'll see, very much involved in what's going on during the time. And the story has it that he was sort of awakened to the love of physics through a guy named Beekman, I think. I always get this wrong. One of these days I'll have to actually write it in a slide so that I remember. Maybe Isaac Beekman, Thomas Beekman, I don't know. Anyway, somebody, where he learned sort of the ideas coming from people like Galileo, that the world is a mechanism which is governed by physical, natural laws. And then Descartes wants to find a place for the mind within that. And so he's a dualist. And he's going to argue that there really are just these two components to reality. On the one hand, there's the kind of stuff that Galileo and everyone is talking about, and we'll talk about it as well. That's the physical world. So this is why the dualism now. Two kinds of stuff in the world, the substances. On the one hand, says Descartes, there are physical things. They are extended in space and time, which means they take up some amount of that space. So a physical body has some definite area or volume associated with it. Physical things, according to Descartes, do not have experience. They cannot think. They are just unextended, senseless matter. By senseless, what they mean is they don't have senses. They're not thinking. They're not feeling. They don't see blue or red. And their motions are governed by these mathematical natural laws. That's the physical world. On the other hand, according to Descartes, there is the mental world. The mental world is the world of conscious thought and experience. It's where you taste chocolate and see blue and have pains and itches and tickles and thoughts about math and formulate physical laws and so forth. It's unextended, according to Descartes, in space or time. So it doesn't take up any space, doesn't take up any amount of time, doesn't exist for a certain period. Not extended, not a physical thing. And he's also a believer in what's known as libertarian free will, which is the idea that actions are produced in a way that no physical law can determine, so that they are unbounded by the kinds of laws which govern the physical stuff that we were previously talking about. Now, that's a very interesting idea, that there are these two components to reality, and each one of them is mutually exclusive of the other. You can't have one thing that has both of these components. Thinking things are unextended. Unextended things are unthinking. Very different. Now, before we jump into the mental side, it is interesting to kind of look at what Descartes says about the physical laws, because he was interested in motion and formulating general laws which described the motion in the physical world. And so he comes up with three laws, and there's some other ones, some corollaries and rules, and we'll sort of ignore all that stuff. But I would like to show the three because they set the tone. So here's the first one that he comes up with. He says, here's this law, that each thing, as far as it is in its power, always remains in the same state. and that consequently, when it is once moved, it always continues to move. And then also vice versa. If it's at rest, it continues to stay at rest. So now what's interesting here is he has this weird phrase in there, as far as is in its power, which makes it seem like, and there is this, if you look back at the history, there are these weird tendencies, and so it does sound a bit Aristotelian if you really get into it, but he's moving towards something that sounds like inertial uniform motion, which is going to play a big role in Newton's three laws, which we're going towards. And of course, that first one, along with his second law, which is that all movement is, if left alone, which means of itself, is along straight lines. That natural motion is always in a straight line. And that motion and rest are natural states of matter. Now this, if you know some history, this is a big departure with the previous views about physics. And in the biggest way is the idea that natural motion is in straight lines. So that may make sense for things here on Earth. You think you drop something, it falls in a straight line to the earth, to the ground. That seems okay. And other things seem to move in straight lines as well, unless you do something to them to make them move around in a curve. But if you look at the planets and the stars, they seem to move in circular motion. And of course, Aristotle had explained that in terms of their being made out of a special kind of stuff called the ether. Excuse me, called the ether. Ether was a special non-earthly kind of thing, like water and fire and stuff, but special. And what was special about it is that it moved in circles. That was its nature. That's what it did on its own accord. Just like if you took a piece of earth, Aristotle thought, and dropped it, it would just move straight down. So too, you took a piece of the moon and dropped it, it would just start moving in circular motion. Now that's a weird view, but that was the view that Descartes' fighting against. And then, of course, if you have this claim that all motion is in straight lines, then you need to have some explanation for why we see circular motion in some places. And of course, that's the big achievement of Newton's theory of gravity, is that you can explain that. And we're moving our way towards that, but I would like to point out that Descartes is aware that you need an explanation of this. His vortex theory is meant to handle this. And this isn't a class on Descartes' physics or the history of physics, although I do have a class on that, the philosophy of physics, and I will maybe someday record those lectures. So, okay. Now, the third law that Descartes formulates is also interesting because it's kind of a precursor to conservation laws, which are going to play a big role in the discussion later on. We start wondering whether the mind can act in the physical world or not, and whether that has any problems with the conservation of mass and energy and momentum and all sorts of things that are conserved. So here's Descartes' third law. He says that a body, upon coming in contact with a stronger one, loses none of its motion, but that upon coming in contact with a weaker one, it loses as much as it transfers to that weaker one. So this actually looks like, could be an early statement of the principle of the conservation of momentum. Momentum and motion, velocity being speed and direction, motion just being moving and speed, and acceleration being change in velocity, and momentum being a force associated with these things. Those concepts haven't been developed yet. So he hasn't quite stated it. But he's got the basic idea that when two things bump into each other, something is transferred. And the amount that's transferred is exactly the amount which is now missing from the thing which bumped. So that's interesting. So that's the way a simplified physical world, which is just, this extended stuff, like you could think of little billiard balls, but they don't have to be round. It's just stuff which is extended. It has these properties of mass and density and shape, and these just physical properties. And it's governed by these kinds of physical laws so that the motions of the universe can be fully described in these kinds of statements, according to Descartes. And those things, by the way, can be stated in terms of mathematics, which we won't do for right now, but you can write down equations which will tell you that these things, how mathematically what these things are saying. So if that's your view about the physical world, then where is consciousness? Where is mind? Where is intentionality? Where is sensation? Where is perception? Where is thought? Well, Descartes believes that those things have to be somehow importantly different. And in fact, they're so importantly different that they require a unique, non-physical, unextended substance in order to have them. And that's the dualism. If it weren't for that, he'd be a materialist, because he would think all there was this extended stuff governed by these kinds of laws. So now, why does he think dualism is true? Well, he gives several arguments, and people debate about what the excuse me. People debate about what the right way of formulating these arguments are. So I'm going to throw out several different versions of them, and you'll get the general idea. When we come back to the more contemporary dualists who have been working in the 1990s, 2000s, like stuff that's happening now, it'll be a lot clearer, because these guys and these people and women, men and women, are very clear about what they're saying. Whereas, looking back on Descartes, it's a little bit harder. But here are some of the things that seem reasonable to say. So here's one argument which he gives. And this comes from his method of doubts, if you've had your intro class. So you can put it this way. I can be certain that I exist. That's the cogito. I think, therefore I am. And really what the I think mean is I'm conscious, therefore I am. I can be certain that I'm conscious. I can't be certain that I have a body. So therefore I'm not my body. That's one argument. Now, the first premise there, that you are certain that you exist, that seems relatively okay. No one really challenges that. No one in their right mind usually challenges that they exist. So, or that they're having conscious experience at this moment. So that seems pretty safe. The second one, though, how can you doubt that you have a body? That seems weird. Like, what do you mean? Here it is, right? You can't see it, but you can hear it. Like, something physical here, right? Well, Descartes thinks not, or at least that you can't be certain of that. And that's because of his famous, evil genius hypothesis, namely that it's possible that right now you're in some kind of dream-like scenario created by an evil genius. And, that seems pretty weird, but given that you don't know it, you can't be certain, it's possible you can work your way through doubting all this stuff. How do I know I'm not dreaming? How do I know this isn't the Matrix? Eventually, Descartes says, yeah, well, you could doubt that you have a body. It's a small doubt, not one that we are too worried about, but it shows that there's some doubt. But there's no doubt that you have a mind. So the two seem different. That's one argument. Here's his other argument. This one comes from thinking about essential properties. So, and this is the one that someone who is liking, coming out of an Aristotelian tradition, would really like, because Aristotle was into these kind of essential properties. An essential property is like something like a defining property. It's the thing which makes you what you are. And if you didn't have that thing, you would be a different kind of thing. So, for instance, if you're thinking about me, what are my essential properties? Well, having two arms doesn't seem essential to me, because you could chop off one of my arms and I would still be me. Same with the other arm. Same with the legs, right? Chop off my legs, I'm still conscious. I still thinking, having experience, etc. And in fact, the only thing that it seems like if you took away from me, you would make me cease to exist, Descartes says, is the fact that I have conscious experience. If you took that away, then I would truly be gone. But anything else you take away, it seems like I'm still there. Like my memories, maybe I'm still there. We can talk about that. Descartes definitely thinks the answer is, yeah, you're still there. Some other people don't. So we'll get to that when we get to Locke a little bit later. But for now, seems okay. Now, the body, well, that seems pretty clear what its essential attribute is. What is it that makes a body a body? Well, Descartes already sort of told us that, and it seems reasonable. A physical body is just something that's extended in space. So that's the thing which, if you took that away, does it have to be a certain shape? No. Does it have to occupy a certain area? Well, no, but it has to occupy some area, is the basic idea that Descartes has. So it seems when you're thinking about these two things, it's pretty clear what their essential attributes are. Bodies kind of, in order to have a body around, you have to have some extended stuff. In order to have a mind around, you need to have some conscious thinking stuff. And so they just seem different, right? You could get rid of the body and still have the mind, get rid of the mind and still have the body. Their essential properties are not the same essential properties. So that makes them a candidate, at least, for being different. Now, even in Descartes' own time, people they didn't like this version of the argument. And people will point out the different responses, but one very simple one, I think, that's nice, is the one that comes from Arnauld. I don't know how to say his name, but Arnauld is good enough for us. The basic idea behind this objection is that, well, even if that is an essential property, it doesn't show that that's all there is to that kind of thing. The example given is of a triangle. You could know some of its essential attributes without knowing others, like that it has three sides, but you might not know the Pythagorean theorem was true of it. That was the example I've seen used in previous lectures. So I think that's a pretty good example to get you to think about this idea that maybe, even if consciousness is an essential attribute of the mind, whether it is or not, we looked at last week, can there be unconscious mental things? Who knows? But even if you think consciousness is an essential attribute of the mind, that doesn't show that it's not physical, because maybe it has other essential attributes as well, like being extended. Now, how you would come to find that out is an interesting question. Okay, so those are two ways of putting the argument. Here's a third way. I can imagine myself existing without my body. And if it's imaginable, then there's nothing contradictory about it. And so it seems like it's a possibility. And if it's a possibility, then I'm distinct from my mind. Excuse me, I'm distinct from my body. So this is sometimes called the conceivability argument, that possibly I'm not my mind, and therefore, why do I keep saying that? Because I am not in my right mind right now. My throat hurts and my head is stuffy. So it's possible that I'm not my body. The way Descartes says this is that, God can make them separate if he wanted to. And you don't have to believe in God to take that point. You can just think of God as, the possibility, the things that are possible make it happen. So if it's possible that these two things come apart, a lot of people have thought that means they're not the same thing. You might use this as a bolster for the second argument. Well, if they come apart, then this is an essential attribute of the other one. Because if you can take it away and still have the thing, it doesn't look essential. Now, we're going to look at this kind of all these conceivability arguments in a lot of detail when we get to the contemporary stuff, because that's where the action has been centered for the most part. For right now, this is good enough to get us where we need to be, which is thinking about whether imagining things has anything to do with reality at all. And that's what we'll be talking about in class. Okay, so here's another way of a separate argument, which Descartes gives, sort of after his official argument, which comes from the stuff we were just talking about. And this separate argument sort of relies on the idea that the mind doesn't seem to have any parts. So he says, I'm a simple substance with no parts. That has a long history of people thinking that real substances are simple ones with no parts, like Plato and the forms. The forms, that's a real substance. It's no parts. It doesn't change. That's good. So you think, well, is the mind really something that doesn't have parts? Well, Descartes thinks that's right. So we talk about willing and believing and sensing. And wait, didn't Plato say there were three parts to the mind? The rational part, the spirited part, the desiring part? Are those separate parts that come literally apart? Well, Descartes says no, that they aren't, and that they are really just different abilities that the whole single mind has. So, for instance, he says, it's not the case that there's a part of the mind that's a sensing part, which you could take off and then it would just be over there sensing, but rather it's the mind that senses. And yes, sensing is a faculty. Perception is a faculty. Willing is a faculty. Imagining is an ability, a faculty. Something we can do. But it's not like the left part of the brain is the sensing, the left part of the mind is the sensing part, and the right part of the mind is the believing part. Descartes says, well, the mind seems like one thing which can do these various other things, but it in itself doesn't have a left, a right, and up, a back, a front, etc. Whereas bodies obviously are things that have parts. And even if it doesn't have parts, we can chop it into parts, because to be a body is to be extended, so you can always cut it. So that sometimes relies on what are called Leibniz laws, and we'll talk about Leibniz in a second. So Descartes didn't know about Leibniz yet, so he's clearly not using something called Leibniz laws, but the basic idea is very simple, and that's that, well, look, if these things are different, then we should be able to find something that's different between them. Here's something that's different between them. One has parts, the other doesn't seem to have parts. Difference. Okay, so now whether those arguments are good or not is not really the point that we're discussing here. We're looking at the consequences of the view, and these arguments are going to be examined in depth later. For now, though, we can point out what the biggest problem is, which is finally getting us to why it's called the mind-body problem, as opposed to simply the mind-body relation. So originally pointed out by Princess Elisabeth of Bohemia, a very well-to-do, educated, intelligent woman. Seems to be that she had some mathematical ability, and was very. And also, if you look her up on, the Stanford Encyclopedia of Philosophy, for instance, you'll find some interesting other thoughts that she had. But for our purposes, we're interested in some letters that she wrote to Descartes, and she had clearly read the Meditations, and she had clearly been educated on the new physics of the day, of which Descartes, as we've seen, was already interested in. And she asked him the following question: how do the mind and the brain interact with each other? Because the physics that she had been studying held that force was communicated by contact, as Descartes' third law even seems to suggest. That although he has other weird things, like, that the thing is, as far as it's in its own power, trying to stay in its state, so that he has a weirdness in his views, but the physics is moving forward without that weirdness. And what it's saying is that force is communicated by contact. And that's doing something, maybe talk energy, we'll get to that later. But the question that Princess Elisabeth poses seems clear that the mind is a force or power in nature. It causes things to happen, and the world causes things to happen to it. So the question for us is, how does that work? Especially if the mind is unextended and the body is extended, so that the physical motions of the body, extended in space, are being produced by the brain, which is extended. So where is this unextended, non-physical mind connecting? Now, one option you could take here is the option of one of Descartes' contemporaries, Thomas Hobbes, who you may have heard of in different contexts, but Hobbes was one of the original commentators on the Meditations, and that Descartes solicited and had published along with his original work, The Objections and the Replies. Oh, excuse me, just riding out the wave of nausea there for a second. So Hobbes is a materialist, and and an empiricist. And he doesn't like Descartes' approach. So it's interesting to look at what he wrote. Remember, just to point out, not everyone was bowled over by Descartes' arguments. Lots of people took it seriously, but there always has been philosophers and scientists who have argued that the mind just is physical. So I'm trying to combat this idea that there's this prevailing notion that dualism's been the dominant view and that somehow materialism is less intuitive. So here's what Hobbes says. He has a very sort of interesting view. There's the world out there. It causes so there's motion in the world. That causes motion in our sense organs by when it contacts us. That motion is then communicated to the heart and the brain. And that in turn, quote, causes a resistance or counterpressure or endeavor of the heart to deliver itself, which endeavor, because outward, seemeth to be some matter without. And this seeming or fancy is that which men call sense. And Hobbes is writing that in 1651. So now notice what's interesting here is it looks like he's trying to account for the intentionality of sensation. When you see red, it looks like you're seeing something outside of you. But clearly, these guys think, and again, go back and look at the perception stuff because of dreaming, hallucination, illusion, whatever it is, there's really something mental which is doing the work. You're not in contact with the thing out there, but it seems like you are. That's the intentionality. It presents it to you as though it's out there. It represents it that way. And notice that Hobbes is trying to explain that in terms of an outwardly directed reaction caused by the inwardly directed impinging motion. That's very interesting, I think. And so, again, I'm not trying to say that he's right. And a lot of people really didn't buy this idea that consciousness just was this kind of motion, this internal motion. But some people did. Some people did. So, and by the way, that explains how the mind and the body can interact with each other. So that's one of the benefits that people like Hobbes have. There's no mystery how this unextended, non-physical spirit thing gets the brain to do something. There's no mystery about that because it's just the brain or the heart. I mean, these guys don't know enough neuroscience. I mean, 1650, so give them a break. Wasn't even discovered that the heart was a pump yet at this point. They didn't know what it was doing. Descartes thought it was distilling animal spirits, which that's a whole separate story, so I don't want to get too distracted here, but there's still a lot of mysteries going on here. There's still a lot of mysteries going on here. But if you think that all that the mind is are motions in the brain, well, then it's not a mystery how those motions could cause other motions given the laws of physics. So you solve the mind-body problem if you're a materialist. Now, of course, then you have to be a materialist. So some people don't want to be a materialist. The people who were influenced by Descartes, but who didn't want to accept materialism, developed various responses. So one of them is from Spinoza here. And I don't know a lot about Spinoza, so I'm sort of just going to tiptoe past this, but he's allegedly a substance monism who claims that the only thing that is real is God, and that everything else which exists is somehow a mode of God's existence, a way that God exists, something like that. It's not clear what that means. And that the thing called God is somehow identical to nature. Now, I don't really know, as I said, I'm not a Spinoza scholar, so we will just quietly tiptoe past that and say, that sounds interesting, people should look into that. And I do wish I knew more about that. I'm just not well trained in the history of Spinoza here. Something I'm currently looking into, though. Okay, so here's another disciple of Descartes. This is Melebranche, and you can see the dates there: 1638 to 715. He's an occasionalist. Now, occasionalism is a very weird view, but it's one that's been around. And the idea is that causation in the natural world is an illusion, and that there's only one real cause of things in the world, and that one real cause is God. Why is it called occasionalism? Because we creatures merely provide the occasion for God to act. Well, that's very interesting. So now occasionalism solves this problem. And because, the mind and body don't really interact, it's only God's interacting. So one way to put this view, and this is the way it was interpreted, is that what Melebranche is saying is that, well, the mind and the body do interact with each other. When you want a sandwich, that causes you to go get the sandwich. When your stomach is feeling nauseous, that causes you to your mouth to water or something like that. There are these effects of the mind between the mind and the body, but each one, on each occasion of those effects, God is doing a miracle, because only God, every action is miraculous. Everything is a personal miracle done by God. Now, some people have looked back in the history of this stuff and said, gee, that's a really desperate move to avoid mind-body interaction. And it's not really fair to Melebranche, because I think he was a occasionalist already. He was a religious person. And occasionalism goes back to the early Islamic philosophers. So this is not a new view in the history of the world. But if you're a Cartesian, it fits nicely with this stuff. So it's not an accident that he's both a Cartesian and an occasionalist. Although I don't think it's exactly historically right to say that, he adopts the one as a desperate way out. But sometimes in the history books, that's what you read. He says, oh, this view's so weird. It must be a desperate reaction to this philosophical problem. Well, actually, it might just be that was his religious view, and the philosophical solution is a nice byproduct of that. And again, we're not doing history. What we are pointing out, though, is that this mind-body problem is a real big problem. People are taking it kind of seriously and saying strange things in response to it. And then for fun, we can throw in Locke, who is here in the mix. And Locke is something that I describe of as a Cartesian empiricist. So he likes Descartes. He likes dualism. He likes mathematical physics. He doesn't like innate ideas, and he doesn't like rationalism. But everything else is like Descartes 101. And the distinction between primary and secondary qualities is you can find that in Descartes as well. And of course, you can find a version of that going all the way back to Democritus, who talks about legitimate and bastard properties in perception. So the idea that that is being developed here is that Aristotle really had it wrong. And one quick way of seeing this is by thinking about heat and cold. So if you want to explain why something does something, Aristotle says, you have to talk about these kinds of properties: hot and cold, wet and dry. And that's a property in the object. So some water will be hot or cold. Some solid will be dry. But the view that Locke is developing, and which Descartes and everyone here basically is developing, is that, well, there's a mistake there. The water isn't really hot, because there are two things you need to separate. One is the motion in the water, which we can call temperature. And the other is the conscious experience of heat, which happens in the mind. And so you get the dualism, the split there. On the one hand, the physical world, where there's just motions. And on the other hand, the mental world, where there's consciousness and thinking. And I won't rehash all of that stuff, but you get the same kind of view here. Now, the kind of interesting twist that comes with Locke is that he thinks the whole substance issue is a kind of red herring. So is the mind a mental substance, a physical substance? He says substances aren't what really matters. And he gives us the cool thought experiment of switching bodies, the prince and the pauper. They switch bodies. The consciousness of you goes over there. So the body doesn't seem to matter because you can switch. And you can do the same kind of thought experiment with non-physical souls. Your consciousness goes from that soul to that soul. So whether, and you can even do it cross. So like maybe the non-physical soul goes into the body or vice versa. Like why can't there be all these weird switches and swaps? And if so, then it seems like, says Locke, the question of what substance is there is irrelevant. And what matters is, do you have the same memories, the same beliefs, the same desires? In other words, the same psychological states, which seem independent of which substance is there. Now, that's an interesting view. And again, we don't want to turn this into a Locke discussion, but we can talk about, what you think about these swapping cases. And we will get to this. There's not enough time in the universe to do everything. So personal identity, sadly, is something I put on the back burner in my lectures, but I understand it's very interesting and people like it. But it doesn't really relate to the question of mind-body in this context. Of course, the big guy here who comes, you can see 1643 to 1727, is Isaac Newton. And there's a portrait of him when he was strapping young lad. And Isaac Newton is, thought of as a physicist, but, I don't see a distinction in this period between philosopher and physicist. And you see these guys are using the word philosophy. They probably mean something like science, but they're doing something like experimental philosophy. They're doing philosophy. They're also doing science. It's all mixed up. And that's as it should. I like things that are mixed up. So what is Newton doing here? Well, of course, he's famous for his 3 laws of motion. And we may as well just throw them out there because we will talk about them. And so his first law of motion says that uniform motion or rest is the norm unless you're acted on by an outside force. So by uniform, what he means is constant rate, straight line. That's uniform motion. So motion in a straight line at a constant rate. Or you're at rest. Now, this gets us into big questions about, well, okay, straight line relative to what, at rest, and questions about the nature of space and absolute time, which Newton had all kinds of views about. And he argues with Leibniz and Clarke, and there's all sorts of cool stuff going on in this period of time about the philosophy of space and time. And if this were, again, a philosophy of physics class, we'd be focusing on that stuff. And again, I do have a class on that, and eventually we'll offer some of that stuff. But here, we're just trying to get a handle on what they take the physical world to be like. And Newton contributes something which really starts people thinking in a certain way. So there's his first law. And I hope you can see that it really is kind of a combination of Descartes' first 2 laws. So something seems similar there. And Newton responds to Descartes in several places where he explicitly tries to attack the view that Descartes has, especially like the vortex theory of planetary motions and those kinds of things, and also some specific details of his physical predictions. So Newton very much was interacting and thinking about the kinds of stuff that Descartes was worried about. Okay, so now we can get to Newton's second law, which is the big famous F equals ma. Even though that's not the way Newton put it. And what's funny is that if you look back in the history of this stuff, people in Newton's own day were going around stating the second law in roughly this way. And Newton didn't like it. He said, no, it's supposed to be, he's put it slightly differently. And it doesn't really matter. We're going to use F equals ma because that's the accepted way that physicists talk about it nowadays. It's what you learn in your physics class. It's standard. So it's also a really beautiful and simple and elegant equation. It's probably one of the most beautiful, simple, and elegant equations that we have. You're going to have some others. Like I think Pythagorean theorem is pretty cool. This is pretty cool. There's some other stuff that's pretty cool too. Equals mc squared, probably pretty famous. But this is nice because it tells you that in general, anything you talk about, so the force there is the net forces, are going to be equal to the mass times the acceleration of the object. And that's really cool because which force you're talking about, it could be any force. It's all of them. It's the net total force. So it's totally general. It's true of any physical object. And that's a pretty cool thing. Now you think about the simplicity of that mathematical statement. And then you realize that Newton is writing it down in the 1650s. He's not writing it down. Other people are. But you get the idea. It's being written down in the late 1600s. And this is 2,000 years after people start trying to do physics. If you think about Thales as being the first person who's trying to do some physics and be serious about it. And then Aristotle and so forth and so on. And then you get F equals ma 2,000 years later. It's such a simple and beautiful and elegant idea. And so much of our knowledge and change in worldview about the world is summed up and codified in that one simple equation. It's really magnificent when you think about it. And I know I tend to wax poetic about F equals ma, but I think it's one of the more startling, brilliant achievements of human beings. And we'll give some details. We're not going to do any multiplication math in this class, but you get the idea. So the third law, of course, is the one that's like so ubiquitous that it's somehow wormed its way into popular culture and mixed with a karma type view. So, excuse me, this is the idea that every action has an equal and opposite reaction. And of course, this can be stated mathematically as saying that, if you use F to equal the forces, the sum total net of the forces is equal to negative force, that force. So for every force, there's an equal and opposite force being applied. And that's true of all forces. Now, of course, in pop culture, people have interpreted that to mean, whatever you do, you get something back in return. And that's a kind of popularization of this idea. But here it's really mathematically defined. So in terms of gravity, for instance, what that means is that the force that the Earth is exerting on you, you're exerting an equal and opposite force on the Earth. So that every force is like that. Equal and opposite forces are being applied at all times. Okay, and then of course there's the big famous thing, the three laws of motion, and then there's also the universal law of gravity. And in case anyone cares about this, the law of gravity says that the force of gravity, so the F here, sub G, is force of gravity, is equal to G, and that's a big capital G for the gravitational constant, and times the masses of the two things divided by the distance between them squared. That's called the inverse square law. Now, what is big G there? Well, it's a constant. It's one of the fundamental values that we find in nature and that we're currently trying to figure out why they're there. Again, this is not a philosophy of physics class, but this is one of the questions. That's a weird looking number. So 6.67 times 10 to the negative 11th. And then look at the units. Meters cubed, kilograms to the fourth, seconds squared. That's a very weird thing right there. But you need it to make the equation work. And it's not something that you can deduce, but it's something that's experimentally determined. You have to actually go and measure it. So this is an interesting thing we found out about the world, that there are these forces and these mathematical equations describe them. Now, of course, Newton was mostly interested in doing experiments, testing this stuff, the predictions of it, and getting the mathematics of it correct. What gravitational force is, he didn't know. He says, I'm not going to posit any explanations of it. But whatever it is, it seemed very mysterious because the force of gravity is holding between us and the Earth, and the moon and the sun over the course of hundreds of thousands of miles. How is it doing that? And we're not touching. So how is this force being communicated between the planets without any touching? People said it looks like spooky action at a distance. It looks like there's something weird going on. Instead of a bumping in communication of one thing to the next, there's some kind of weird distancy relation between them. And of course, this got a lot of people thinking. Maybe this gives us a way to think of the mind, people said. Well, the force of gravity is real. It works, and it works, removed at a distance. So maybe the mind is like that. Maybe the mind is like the force of gravity. It's like a fundamental force in nature, and it affects the physical world. But it's not, you can't point at it because you can't point at gravity either, but it's real and can be described. And what's interesting is if you look back and you read through this stuff, you see that people use this is where the term nervous energy comes from. Nervous energy is supposed to be sort of the equivalent of kinetic energy, which is the paired with potential energy. And we'll talk about that in just a second, of course. But the idea is that nervous energy was supposed to be like that. It was the energy that the mind could use and which could be converted into kinetic energy in the physical system. Just like the force of gravity somehow converted, generated kinetic energy, would move things down. That's a very interesting idea. And so people thought, that, well, there's nothing really at odds with physics here, right? In fact, Newton's weird new physics, which it gets its reputation from math and prediction, seems like it supports it. Now, of course, if only things were that simple, then they would have continued that way. So now we can introduce Leibniz. And Leibniz and Newton are alive around the same time. And they are credited with co-discovering calculus independently. It's not clear exactly to what extent Leibniz knew of the work of Newton and vice versa. There's some hints maybe they did, maybe, I don't know. So it's complicated. We don't want to do too much history here, but these are two mathematical geniuses that we're dealing with here. And Leibniz is associated with developing this really weird, far out, wacky view called parallelism, which is that the mind and the body are two distinct substances. He has a whole view about substances. He calls them monads, and we don't really care about that, but that's what he calls them. And these two distinct substances run in parallel to each other, but never interact with each other. This is something that he called the doctrine of the pre-established harmony, that God had just made them so perfectly that they lined up automatically without any interaction between them. One kind of analogy, which sometimes people appeal to in this way, is if you take two pendulums and if they were sort of swinging back and forth in different, out of sync with each other, over time they'll sync up. And you can look up this on YouTube. There are videos of this. I saw one that was really cool of like 60 of these harmonic oscillators gradually coming to sync up. Each pendulum at a different period, basically. Okay, so you don't care about that. But the idea that he has is, well, look, these things don't interact with each other, but somehow they sync up in perfect harmony. And that the physical world just kind of, and the mental world were made so perfectly that that's what happens in nature. Now, that's a far out view, that these substances don't interact, that they're parallel. Sometimes people try to explain it by analogy to what goes on in the movie theater. You see the pictures on the screen, you hear the sound, it looks like they're coming together, but they're really two different tracks, the visual track, the audio track, joined up so it looks like they go together. Now, you might say, why would anybody in their right mind have this kind of view? And it turns out that the part of the answer is that Leibniz was really good at physics, and that he was discovering what is later going to be called the conservation of energy. The conservation of energy roughly says that energy is not created or destroyed, but only changes form. And this really blossoms into the theory of thermodynamics. And we're not really worried about a lot of this stuff, but you have to get the general flavor of what's going on here. And this has to do with energy and the transfer of energy. And energy is defined as the ability to do work, where work means producing some kind of change in the world. For instance, if you move something a certain distance, you must have performed some work in order to move it. And energy is the thing which lets you perform that work. So these are the way that physicists define these terms. Now, work you can define mathematically. It's the force applied over the distance that it's applied. You push it so hard for 5 feet, for instance, that kind of thing, right? So in your basic elementary, high school level physics class. That's what you would be doing. Okay, so, but of course, we need two concepts to really do any kind of interesting things here. And those are the concepts of potential energy, which basically is the energy that something has. And to simplify, I'm only going to be talking about gravity because I think it's the most familiar of the forces, and it's the simplest one to talk about for right now. So suppose that, this is the way you take your physics class, you go in there, they say you're holding a ball, you're holding a ball 10 feet above the ground, whatever. So the ball has some energy, potential energy, which is stored there. And you can measure it by calculating the mass of the object times the gravitational constant, times the acceleration due to gravity, not big G, this is little g, times the acceleration due to gravity, and times how high it is. And that gives you a measure of how much potential energy that is there. How much can be converted to kinetic energy, which we have another mathematical formula for. It's 1/2 mv squared. So you take 1/2 of the mass times its velocity squared, that tells you how it's kinetic energy. And these two things are always being converted one into the other. Kinetic energy is converted into potential energy, as when you throw the ball up, it's got kinetic energy being converted to potential energy. At the top, it's full potential energy. As it goes down, it's being converted back to kinetic energy. Okay, so the long story short of this is that what the physicists are discovering of this day is that it looks like any physical system you consider is one in which energy is conserved. You start out with a total finite amount. Some work is done and some energy is converted into a different form. And the forms it can be converted to are various. Heat through friction, for instance, is one kind of conversion. There are chemical convert. So there's many different ways of converting the potential energy into kinetic energy. But the idea is that wherever you look, it seems conserved. You don't add any in and you don't get any out. Now, that's not automatically a refutation of dualism, but it looks like you're starting to build up a case. The case is that the two systems are isolated from each other because the physical system has only physical energy in it. You're not getting any new energy in or old energy out. And so, some people say, well, maybe the mind's just contributing a tiny little bit and we can't measure it. Well, that's a possibility, but it doesn't seem likely given that the conservation laws seem to be racking up. So it's interesting that this starts with Leibniz and that it is part of the explanation for why he adopts this radical view. The physical world and the mental world just seem to be separate from each other. Now, of course, if that's too weird for you, you could go Berkeley's route. And Berkeley, of course, was an idealist. He argued that the mind-independent world doesn't exist, that everything is an idea in God's mind. And of course, that solves the mind-body problem because there's no question about how the mind and body relate. If there's no body, there's just mind. So it's just mind-mind relations. And so you think, physics is progressing in a certain way. And people, in order to make their views of the mind, which start with Descartes, compatible with what the physics is describing, they're finding themselves forced into these really weird views because we can't make sense of the way that these two things are interacting. Every time we try, it seems we run into a problem. All right, so I won't talk about idealism. You can get that somewhere else. Now, I'll just mention Euler here. He doesn't really have anything to contribute to the discussion that we're having, but you have to mention Euler. He's a genius, probably the greatest mathematician ever to have lived, if I may say so. I mean, I'm not a mathematician myself, so someone could correct me, but I would put Euler as one of the top greats. And not only does he do like everything in mathematics, but he puts the equations that come out of Newton in the form that you would recognize them today. So, little p for momentum, it's a differential equation. This all comes from Euler, and I just thought, well, it's important that we throw him throw him in there as a part of this mathematization of physics. Okay, and then finally, we culminate here with Immanuel Kant, who a lot of people have really seen as trying to defend this Newtonian worldview from the attacks of various critics, and chief among them the critic being David Hume, who argued that we just didn't have any good reason for thinking that these mathematical descriptions were necessary features of reality. And Kant develops his whole transcendental idealism as a response. At least that's what he says. I mean, he says he was awakened from his dogmatic slumber by Hume. And again, I'm not going to spend any time with Kant. I'll just say that he's led to this really radical view, which is the ultimate, logical result of the view that starts with Descartes, you might think, which is just that the two things are radically separate. You can't interact. The phenomenal world is cut off from the noumenal world. The noumenal world where freedom and all these weird things live. The phenomenal world is completely determined by the laws of physics. That's the way you connect the two up. And you just end up with this really radical isolationism. That seems to be the problem, which is coming to the forefront here, is once you start to mathematically describe physics and you take out things like the redness of red, and you're just left with the wavelength of light, and you take out the sweetness of sugar, and you're just left with the chemical structure of the sugar molecule, and you take out the wetness of water, and you're just left with the hydrogen and oxygen cationic bindings. When you take out all of the mind stuff and you're just left with the physics described by math, then you have this really mysterious problem of how the two worlds relate to each other, how they causally interact with each other. Every door seems to be slamming shut. And so we're going to pick this question up next week when we start discussing the view known as epiphenomenalism, which is the claim that the mind just doesn't interact with the physical body at all. And see you then.